Alright guys, we're going to be solving another question from the chapter 5 of Meriam textbook Engineering Mechanics. We have this I-beam that supports the 1,000 pound force and 2,000 pound foot couple applied to the 2-foot strut welded to the end of the beam. We need to calculate the shear and the moment M at the section midway between A and B. So we're talking about the middle of this, which is going to be 1.5 from each side, and we're going to do our section in this part in order to find the unknowns in here. But before that, we're going to find the reactions that we have at these two supports. So from the free body diagram of the whole beam, we're going to have one force in here, we call it AY, and we can consider two forces BX and by in here since we have a pin. So we're going to consider both x and y, and at A we have a roller. Since we are neglecting the friction, we only have the vertical component. We can show our x and y in here, and from the free body diagram of the whole beam, if we just do the moment about point B counterclockwise positive, we should be able to find the AY in here. So the moment of AY about B will be in this direction. So we have a clockwise moment, so minus AY times the distance from A to B, which is 3 feet. And we're going to have the moment of the 1,000 pound force. So we're just going to break it down into two components. The horizontal component won't make any moment because it's going to pass through the point B. So we're going to have the moment of the vertical component or the Y component. This one's going to make a counterclockwise moment, so positive 1,000. And for finding the vertical component, we're going to have 4 over 5. We know this right triangle, the hypotenuse would be 5 because it will be the square root of 4 squared plus 3 squared, which is 16 plus 9. So the square root of 25 is going to give us 5. So the vertical component would be 4 over 5. So that's going to be the force, and the distance from this end of the beam to B would be 3 plus 3, which is 6. And we're going to have the couple at the other end of the beam, which is also counterclockwise, so plus 2,000 equals 0 since we are in equilibrium. So our AY would be basically 2,000 plus 200 times 8, 200 times 4, which is going to be 8. So 800 times 6, 4,800 divided by 3. So we're going to have 6,800 divided by 3, which is going to give us 2266.67. So now that we have A, we can just do our section at this point, and we're just going to draw the free body diagram of the left half of this beam because we already have the AY. If we want to go with the right portion of this beam, we have to find BX and BY, but we don't need to, it seems. So it's easier to go with the left half. So that would be our section, and we're going to have one shear force V. We're going to have one axial force, which the question is not asking. We're going to show it with N, and the bending moment in here. We also have the 1,000 force that is applying in here. So if you just call this point maybe point C, and also we're going to have the AY, which is applying in here. Our AY, we figured that it's 2266.67 pound. And from A to the left of the beam, this is going to be 3 feet, and this is going to be 1.5. Again, because the question is asking that our section is in the midway between A and B. We know A to B is 3 inches, so 3 divided by 2, 1.5. So we're just going to find the moment about point C, counterclockwise positive. We're going to have the moment of our couple, or we're going to have the bending moment, which is positive. We're going to have the moment of the Y component, which we figured is 800 from the previous step. So this was our Y component. So this will be 800, and the other one would be 3 over 5. So this is 600 pounds. So we're gonna have the momentum y component again counterclockwise, so plus 800 times the distance 3 plus 1.5, and we're gonna have the moment of uh, the reaction at A, which is clockwise, so negative 2266.67, and the distance from C to A would be 1.5, and this will be equal to 0, so we should be able to find the bending moment, which is going to be, so 2266.67 times 1.5 minus 800 times 4.5, that's going to be minus 200 pound-foot. The negative sign shows that the bending moment is actually clockwise. So we just have to find the force V in here. So for that, I'm just going to do sum of all forces in y equals 0. So we're going to have minus 800, which is the y component of 1,000 pound force. We're going to have A was 2266.67. We're going to have minus V since it's downward equals 0. So our V would be 2266.67 minus 800, or 1,466.67 pounds. We did not get any negative sign, so that shows that it's actually downward. And the question is not asking for the axial force, but if you want to find that, we just have to do sum of all forces in X. And yeah, that's pretty much everything for this one. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.